Hi, in this video I'm going to cover sections 1 and 2.1 of your lab handout for lab 1. Now that corresponds to setting up the equipment, building the RC circuit, and then taking the first measurement, which is the step response of the RC circuit. So let's get started. First, we're going to start the oscilloscope. So we're going to double click on the Waveforms app, and after a few seconds that should open up a desktop application which allows you to communicate with the 82. So click Scope, and that should start a brand new empty oscilloscope screen. Now if for some reason this is not empty, like if you used it before, and you want to start a clean empty oscilloscope, just head over to File, click New Scope, Empty, and that will start a clean empty oscilloscope. Now before we build the circuit, we need to make sure that our 82 is set for the DC coupling. So you'll see this small button that has a settings icon next to channel 1. Click that button and you should see coupling, and it should be set to DC. Now as you can see on my screen, I don't have the option to change between AC or DC coupling because I don't have a BNC adapter board connected to my 82. And most likely you will not have a BNC adapter board because it does not ship with the student version of the 82. In any case, if you do have the option to change between DC and AC, double check that your coupling is set to DC so that everything will work fine. Also in channel 2, do the same thing. As you can see here, it's set to DC coupling for both channel 1 and channel 2. Now let's set up the hardware. So we're going to build the RC circuit that's in figure 1 of your lab handout with the values R equals 1 kilo ohms and C equals 1 microfarads. So go to your kit, and you should first take out a 1 kilo ohm resistor. And a 1K resistor has the color combination of brown, black, red. So find the resistor that has brown, black, red color combination on it, take it out of your kit, and place it in the circuit. Next, we're going to take out the 1 microfarad capacitor. So for this, we're going to have to use an electrolytic capacitor. And so when you're setting up this electrolytic capacitor, be very careful, because if you apply a voltage of the wrong polarity to this electrolytic capacitor, it will blow up. So you have to double check before you start the waveform generator that this electrolytic capacitor is in the right direction. So now to make that easy for you, there's a black line on one side of the capacitor which says minus. That will go to ground. So we can do that already. Look for the black line on the electrolytic capacitor and connect that to ground. And as you can see here, I'm going to set this whole column here to be my ground rail in just a moment. So connect that to ground, and then connect that to the resistor. Now I'm going to set up ground to be along this entire rail over here. This is going to be my ground rail. So you'll see that in the 82 there's 4 black wires connected to this thing here. Any one of the 4 black wires represent ground, so it does not matter which one you choose as long as it's a black wire. So I'll take this black wire, I'll take a jumper wire from my kit, connect it to it, and then connect this to the ground rail. Now this entire rail here will all have a ground voltage of 0 volts. Now we have ground connected, we have the capacitor connected to ground, and we have our resistor. That's basically it. Now what we have to do is just set up the oscilloscope probes so that we can actually take measurements. So we're going to measure the input voltage across channel 1 and the output voltage across channel 2. Now one thing we have to do before we set up the oscilloscope measurements is we actually have to apply the input voltage to the circuit. And the input voltage, it comes out of this yellow cable here, which is labeled W1. It stands for waveform 1. This cable will output the voltage that we're going to set in the waveform generator. So take this cable, I'm going to connect a flat wire to it, and connect that to the positive terminal of the resistor. So we have our ground, we have our capacitor, we have our resistor, and we have our V in of t, our input voltage. Now, literally, all we have to do is just connect V out of t, which is going to be the measurements on the oscilloscope. So, as you can see in your lab handout, we're going to measure V in of t, this yellow input voltage across channel 1, and we're going to measure V out of t, the voltage across the capacitor in channel 2. So first I'm going to set up channel 1. On the far left side of your 82, you should have this orange cable here. This orange cable is scope channel 1 positive. So it's the positive terminal of channel 1. So we're going to connect this scope channel 1 positive cable to the same node as V in of t, since we're measuring V in of t on channel 1. So I'm going to connect an orange flat wire to scope channel 1 positive, and I'm going to connect that to our V in of t node. Now that's not it for channel 1. What the oscilloscope is going to do is it's going to look at this channel 1 positive cable and then this channel 2 negative cable, and it's going to show you on the oscilloscope plot the difference between channel 1 positive and channel 1 negative. So we want to connect our oscilloscope channel 1 negative cable to ground. Now to find your oscilloscope channel 1 negative cable, it's going to be directly below the orange cable, and it's also going to be orange but with a white strike through. So I'm going to connect this directly to ground so that we're actually measuring V in of t. Okay, so we have channel 1 of the oscilloscope set up. Now the very last thing to do in building this circuit is to set up channel 2, which is we're going to measure the voltage across the 1 microfarad capacitor. So right next to the channel 1 positive cable is going to be channel 2 positive cable, labeled 2 plus. It's the solid blue cable, and it's going to measure the voltage on channel 2. So take this blue cable labeled 2 plus, and we're going to connect it to the positive terminal of the capacitor, which is this node right here. And the last thing, like in channel 1, is we're going to have to set the channel 2 negative cable to be at ground so that the oscilloscope measures the voltage across the voltage at this point in the circuit minus 0, which is ground. So, like channel 1, the oscilloscope channel 2 negative cable is this blue cable with a white strike through. It's directly below the solid blue cable, which is scope channel 1 positive. So take this blue cable with a white strike through, and I'm going to connect a flat wire and connect it to the ground rail as we did for channel 1. And that's it. Our circuit is built. Let me just double check this is right. Yep. Okay. So now what we're going to do is we're going to make our first measurement, which is in section 2.1. So the goal of section 2.1 of the lab is to measure the step response of the RC circuit that we built right here, and to compare it with the theoretical measurements that you should have done in your pre-lab and that I also redid in the introduction. So, we assembled the RC circuit on the protoboard. Now, we need to generate a 1 volt step function in the 82. Now, the only issue is that there is no built-in step function in the 82. So, what we're going to have to do is we're going to have to apply a very low frequency square wave and then set the time axis to be small enough that it looks as if it's a step function. So, before we do that, let's make sure that our time division and voltage divisions are correct. 1 millisecond per division for the time axis, 500 millivolts per division for both channel 1 and channel 2. That seems right. Now, what we're going to have to do here is, because we're measuring a width of 10 milliseconds, that's not enough time for us to click, like say, run and then click stop. So we're going to set a trigger, and then what the oscilloscope will do is that when you set that trigger, once it sees the voltage above that trigger, it'll fill the screen with the plot. So we're going to set the trigger voltage on the oscilloscope to be 500 millivolts, which means that once the oscilloscope sees a voltage of 500 millivolts in channel 1, that's our source, then it'll start plotting. and it'll plot until it fills up the screen, and then once it fills up the screen, it'll stop. So we have our trigger set. Our condition is rising. Source channel 1, mode repeated normal. Now the reason why we have mode normal and not mode auto is because if mode auto does not see the trigger voltage within 2 seconds, then it shuts off. So now we want it to sit at normal so that it will continuously wait until it sees the trigger voltage, and then it will fill the oscilloscope plot. So change that to normal. Okay, so we have all of our oscilloscope settings configured. Now we're going to generate our quote-unquote step function. So head back over to the main waveforms display, go back to the welcome screen, and click the WaveGen button to head over to the waveform generator. Now what we're going to do is we're going to have a low frequency square wave, which is going to represent the unit step voltage. So make sure that this is simple. Change the type to be a square wave. Now we're going to use very low frequency, so 10 Hertz. Oh, that says 10 kilohertz. 10 Hertz, and you could have also done 100 milliseconds. Now I just want to think about something here. A period of 100 milliseconds, because you're probably wondering, does this really work? Is applying a square wave, will that really work? So a period of 100 milliseconds means that the square wave will be on for the first 15 milliseconds of its period, and then it will be off for the next 15 milliseconds. So in our oscilloscope plot, because it's only going to be on for 5 milliseconds, that's well within the 15 millisecond range before it turns off. So when we plot it, it will really look as if it was a step function. Now there's one last thing we have to do. Right now this square wave is between -1 and 1. We need it to be between 0 and 1, so what we're going to have to do is we're going to have to scale the whole thing down by 1/2. So change the amplitude to 0.5 volts. And then we're going to offset it by 500 millivolts or 0.5 volts so that we get a square wave from 0 to 1. So change the offset to 500 millivolts. Alright, we have our square wave configured. Now we're ready to collect our output. So first head over to the oscilloscope, press single. Now what single will do is it's going to capture a single acquisition, which is just a fancy term for what I explained earlier, which is it's going to wait till it sees the trigger voltage, and once it sees the trigger voltage, it'll fill the oscilloscope plot, and then once the oscilloscope plot is full, it'll stop plotting. So click single. Then head back over to the waveform generator and click run. And from what I see here, something's wrong with my channel 2 measurement. So it turns out that actually the issue was that this small wire here, which is to measure on channel 2, it wasn't fully connected. It was actually like sitting right at the end of it, which is why you saw a small like weird output initially, and then the output went to 0. So make sure that all of your cables are connected thoroughly, and that these wires are pushed all the way in and pushed all the way into the breadboard, so that something like that doesn't happen. Now, before I move on to the next part, I want to show you something that is an issue that you might likely run into when you're doing the lab. Let's suppose instead of connecting the capacitor here, I connect the capacitor here. I mean, I told you at the beginning this is all ground rail, right? So let's plug it into ground. And guess what? Nothing comes out. So what's the issue here? It turns out that if you look closely, there's a white block sticker here that the way they designed this protoboard is that the first top ground rail is separate from this second ground rail. So this is not ground here. Now, sometimes it's unavoidable that you'll end up using all different positions along this entire ground rail. So what I would do just to be safe is take two small wires and short this ground rail with the second ground rail, so that now both ground rails are both 0 volts, the same ground. Okay, I got one in, and just for consistency, we can do the other rail as well. And so if I were you, I would leave these two wires always on your protoboard just to make sure that something like that doesn't happen and you end up spending hours trying to debug your circuit when in fact this is a different ground from this. So this concludes section 2.1 of your lab handout, and in the next video I'm going to go through section 2.2, which is determining the pulse response of the RC circuit.